Have you ever been assigned a project about acids and bases and had no clue what you were doing?
I don't understand.
Has your chemistry teacher ever tried to teach you a lesson about acids and bases and it ended up looking like this?
Thanks, Obama?
Have you ever burned your skin with a liquid and had no idea why?
Ow!
Has a member of your family suddenly died after drinking a liquid? Oh no! No! If you've encountered any of these problems, then you need the SKAB in your life. No, really, we've helped tens of high schoolers understand this complex topic. Yeah, it works. Ma'am, we paid you to say that the product works.
The product works.
I used to be dumb, slightly less dumb.
It changed my life for the better.
I actually still haven't gotten mine in the mail. It's been like 60 days. I was just kind of wondering. The SKAB comes with 7 different video guides about various topics for the low price of $24.99 a month for 3 years. But wait, there's more. If you order now, we'll even throw in our very own completely trustworthy pH tester. It works! Don't turn off your TV now, because it even comes with a set of highly professional flashcards covering important definitions relating to titration, and even some example titration curves. And now, we'll even preview each of the video topics just to show you what you're missing. Section 1. Properties of acids and bases.
Here we have some battery acid. You take your litmus paper, you put it in the battery acid, and you see it turns a shade of red.
This is because acids turn litmus paper red.
Now we have some baking soda dissolved in water. This turns the litmus paper blue.
This is because bases turn litmus paper blue. Hello, Krista.
How do you know my name?
That doesn't matter. Drink this. Go ahead, drink it.
That tastes sour.
You know what else tastes sour? Acids. Oh, don't worry, you didn't drink one. I just wanted to prove a point. You see, acids taste sour and bases taste bitter, but you shouldn't drink them. Now, Krista, just continue drinking your sour beverage. It's okay, I promise that's not acid. Another property of acids and bases is how they feel. Bases feel soapy or slippery. This is because they're making the outermost layer of your skin dissolve. Meanwhile, acids will sting if you get them in an open wound. Let's see what happens when Krista comes in contact with everyday acids and bases. Here we have Krista doing the dishes with soap, a weak base. Krista, what does that base feel like?
It's soapy.
Do you know why?
No.
That's because it's a weak base, so it's making your skin dissolve.
Is that dangerous?
No, you can keep doing the dishes. It's a weak base, so it can't harm you.
Ow!
Oh, you have an open wound. Let's see what happens when she comes in contact with an acid. She screamed because acids sting. The app even comes with a very helpful and very detailed and long PowerPoint about acids and bases. Let's take a look at just 2 of the slides. Properties of acids and bases. Acids give up a proton, while bases accept a proton. Let's take a look at electrons. Acids accept a pair of electrons, while bases donate a pair of electrons. To see the rest, buy SKAB for $24.99 a month for 3 years.
Let's see what happens when we mix an acid and a base. Here we have an acid and a base. Wow, it formed salt and water.
Now, Krista, do you know why an acid and a base form salt and water when you combine them? That's because acids and bases neutralize each other.
This is a base and this is an acid. Watch what happens when we pour the acid into a base. It doesn't change. This is called a buffer.
Let's take a look at the final property of acids and bases, whether or not they conduct an electric current. So here we have an acid. Let's see what happens.
Ow!
Wow, acids conduct electricity. How about that base?
Ow!
Bases conduct electricity too. And that's all we have for SKAB's properties of acids and bases. One important thing we have to talk about when talking about acids and bases is the pH scale. This is a scale ranging 1 to 14 that tells you how acidic or basic a solution is. 1 to 6 is acid, 7 is neutral, and 8 to 14 is base. Now let's test what distilled water is. Here we have our litmus paper. Let's put it in this water. As you can see, nothing's happening. It remains the same color. That's because it's neutral, which means this water is perfectly distilled. Now let's take a look at some common household objects and where they're placed on the pH scale. Here we have battery acid at 1, lemon juice at 2, tomatoes at 4, egg yolks at 6, distilled water, as we just discovered, at 7, seawater at 8, baking soda at 9, and common detergents at 11. As you can see, many things can be placed on the pH scale. To our next topic, acid and base definitions. Now there are many people who have an idea of what an acid and what a base means. Let's take a look at 3 of the most important definitions. This definition of an acid is a substance that increases the concentration of hydrogen ions when added to water. This definition of a base is a substance that increases the concentration of hydroxide ions when added to water. The definition of an acid is a compound or ionic species that can accept an electron pair. Meanwhile, a base of this definition can donate an electron pair. This acid is one that donates hydrogen ions. Meanwhile, this base is one that accepts hydrogen ions. Now let's take a look at our highly professional titration cards. We even fixed the spelling of titration.
Titration. What? Titration is a technique where a solution of known concentration is used to determine the concentration of an unknown concentration. The titrant, known solution, is added from a burette to a known quantity of the analyte, unknown, until the reaction is complete. An indicator signals the end of the reaction. Commonly used equipment: burette, Erlenmeyer flask, magnetic stir plate, pipette. The equivalence point is when chemically equivalent quantities of acid and base have been mixed. It is found using an indicator. The endpoint is the point at which an indicator changes color in a colorimetric titration that signals the end of a reaction. An indicator is a device that allows the pH of a solution to be determined visually, a chemical detector for hydronium and hydrogen ions. An example of a titration calculation. Titration reveals that 11.6 milliliters of molarity of 3-sulfuric acid are required to neutralize sodium hydroxide in 25 milliliters of sodium hydroxide solution. What is the molarity of the NaOH solution? You calculate first the moles of the standard solution, calculate the moles of an unknown solution, then calculate the concentration of the unknown solution. Hint: moles equals concentration times volume in liters. Here's how you solve it. Under each of the steps are our work for each step. First, you write the reaction equation. Then you get to liters. Then you calculate the concentration of the known. Then you use stoichiometry, and you can calculate your answer. Titration curve. A titration curve is a graph of pH versus volume. It can be used to determine the equivalence point by analyzing vertical sections. Strong base titration, strong acid is shown here. The strong base titration, weak acid is shown here.
Let's talk about calculations with pH. You can find the pH using the concentration of the hydrogen or OH ions. For instance, if you had an HCl solution with a molarity of 0.0025, what would the pH be? Let's take a look. Alright, pH is the negative log of the concentration of the hydrogen ions. So, you would do the negative log of 0.0025, and you would end up getting 2.6 as your pH. What about pOH? Say you had a solution of hydroxide ions of a concentration of 4.82 times 10 to the negative fifth molarity. So the pOH would be the negative log of 4.82 times 10 to the negative fifth. You would end up getting negative 4.32, which ends up being a pOH of 4.32. Now, how could you switch between pH and pOH? Say you had a pH of 6.7. It's simple. All you have to do is 14 minus 6.7, and you get a pOH of 7.3. Let's go backwards. Say you had a pH of 8.34. How could you find the concentration of the hydronium ions? Well, you'd plug your numbers in. 8.34 equals the negative log of the concentration of your ions. Another way to write this equation is simply to say 10 to the negative 8.34 equals the concentration. It ends up being 4.57 times 10 to the negative 9th molarity. The equilibrium of acids and bases are when they're combined and the pH is neutral at 7. The value of this is 1.01 times 10 to the negative 14th at 25 degrees Celsius. So call now to get yours. 123-555-SKAB.
This method was only successful on students who already had an understanding of acids and bases. Side effects may include a rash, slight headache, acid burns, permanent blindness, stomach cramps, and death. Warnings: if you ingest the litmus paper, please see your doctor immediately. Also, contact your doctor if you develop a sudden fear of pickles. The SKAB costs $2,499 a month for 3 years. Also, we may own your house.